In this video, we are going to discuss about the effects of negative feedback amplifier. So first topic is stability of gain. A gain of the negative feedback AF is equal to A divided by 1 plus A beta. If I partial differentiate the AF with respect to A, I will get dou AF divided by dou A is equal to 1 divided by 1 plus beta A the whole square after applying the U by V formula. In this formula, I am going to multiply and divide by AF on this side. Since we know that the value of AF is equal to A divided by 1 plus beta A, and the AF here I'm moving it to left hand side. So I can write dou AF by AF divided by dou A by A is equal to 1 divided by 1 plus beta A. This term is called as a sensitivity. The inverse of sensitivity is desensitivity. Dou AF divided by AF is a fractional change in the amplification with feedback. And what is dou A divided by A? This is nothing but a fractional change in the amplification without feedback. Desensitivity, that is equal to 1 plus A beta. And S is equal to 1 divided by 1 plus A beta. The gain of the negative feedback is decreased by the factor of D. If D increases, the gain get decreased. The gain and stability is inversely proportional, so the stability is increased if we increase the desensitivity. So we will going to see the problems. We are going to see the problem on this above equation. What is the problem? An amplifier with an open loop gain A is equal to 200 plus or minus 150, which is available, and it is necessary to have an amplifier whose voltage gain which varies by not more than plus or minus 0.2 percentage. Calculate the value of beta and AF. Here A 2000 and dou is 150. This is a change. Dou is 150 and A is 2000. For the feedback, after the feedback, AF is 100 and dou AF is 0.2. Substitute the value, you will get the value of A beta. We know the value of A is 2000. Substitute the value and you will get beta is equal to 0.1825. Find the value of AF. AF is equal to A divided by 1 plus beta A. Substitute, you will get the value of AF is equal to 53.33. Regarding distortion, due to the introduction of negative feedback with feedback ratio beta, the distortion get decreased. Distortion we usually represented as D. So D is reduced by 1 plus A beta. So this D represent distortion, and this is a desensitivity. Okay. Due to the negative feedback, distortion get reduced by 1 plus A beta. The value of A is equal to 400 and beta is equal to 0.01, and the value of D, distortion is 10% without feedback. Substitute on this formula, 10 divided by 1 plus 400 into 0.01. So if I substitute this value, you will get D is equal to 10 by 5, that is nothing but 2%. Since they have represented in percentage, due to the negative feedback, noise they are represented as N. Noise with feedback is represented as NF, that is equal to, due to the negative feedback, noise also reduced by the factor of 1 plus A beta. The negative feedback reduces the noise or interference in an amplifier more precisely by increasing the ratio of signal to noise, which is possible only under certain condition. Usually the signal to noise ratio is represented as S by N. You can see the improvement in signal to noise ratio because the noise value is in the denominator. If the noise get reduced, there is an improvement in the signal to noise ratio. This can be achieved by connecting a noise-free amplifier before the noisy stage with the application of negative feedback. We will discuss the rest of the topic like frequency, bandwidth and the bandwidth product in the rest of the videos. You can see the gain bandwidth product of the gain bandwidth product, that is A beta. bandwidth. Gain into bandwidth product of the amplifier with negative feedback is same as AF into bandwidth of without feedback is similar to with feedback. So let us discuss one more problem on the previous formula. So they have given mid-range mid frequency range, mid frequency gain. So that is nothing but A is equal to 200 and the frequency response is from 100 hertz to 20 kilohertz. In beta value is equal to 0.02. Determine the new system performance. Okay, after applying the negative feedback. So we know that AF is equal to A divided by 1 plus A beta. So you substitute the value 200 divided by 1 plus 200 into 0.2. So that is nothing but 40. And we know that FLF is equal to FL divided by 1 plus A beta. So here they have given FL is 100, lower frequency. So 100 divided by 1 plus 200 into 0.2. So if we solve, you will get 20 hertz. Similarly, FHF is nothing but FH into 1 plus A beta. So that is nothing but 20 kilohertz into 1 plus 200 into 0.2. That is nothing but 100 kilohertz. So what is generally the bandwidth is nothing but 20 kilohertz minus 100 hertz. Okay, so this is a bandwidth. So we can approximate as 20,000, right? 20,000 minus 100 hertz. Next, bandwidth with feedback is equal to FHF minus FLF. That is nothing but 100 kilohertz minus 20 hertz. So we can generally approximate this one as 20 kilohertz and this one approximate to 10 kilohertz. So you substitute in this formula. So what is A? That is nothing but AF into bandwidth of F. So you solve this one, 200 into 20 kilohertz, that is equal to 40 into 100 kilohertz. So you can see both the values are very much similar. So this shows that the gain of the gain bandwidth product of the amplifier with feedback is same as gain and bandwidth without feedback. Thank you.